Welcome to Lesson 8-7, Three-Dimensional Figures. Today we will learn how to classify three-dimensional figures and how to draw three-dimensional figures. First things first, in order to understand a three-dimensional figure, you have to know what a three-dimensional figure is. A three-dimensional figure is also referred to as a solid. It is a figure that does not lie in a plane. And it doesn't lie in a plane because it has three dimensions to it. It has length, width, and it has height. A plane will only have a length and a width. Okay, so any figure that kind of pops out at you is considered a three-dimensional figure. Faces are the flat surfaces of a solid shaped like a polygon. So if you were to think of this as a home, all of the walls and the ceiling and the floor are considered the faces of the three-dimensional figure. An edge is the segments formed by the intersection of two faces. So anywhere that your walls meet, or where your walls and your ceiling or your walls and your floor meet, those are all edges. And a vertex. We learned about vertex with angles, but it's a little bit different with a three-dimensional figure because here it's a point where three or more edges meet. Okay, so any of your corners are your vertexes. Alright, so first we're going to identify the number of faces, vertices, and edges on each of the three-dimensional figures. What I like to do is I like to look at the base of the figure. Now in this case, we have a rectangle. I know that since this rectangle has four sides, that off of those four sides has to come another face. So there's a face on the bottom, this face here on the side, the face on the top, and the face in the back. So there's four. It also has to have a bottom, which we see right here, and it has to have a top. So this has 6 faces. Now, the bottom and the top each have 4 edges. 1, 2, 3, 4. 1, 2, 3, 4. In order to connect each of those, the top and the bottom, you have to have an edge going from corner to corner. So if there's 4 down here and 4 up here, then you have 4 in the middle. So this shape has 12 edges. And then the corners. So there are 1, 2, 3, 4 vertices down here. 1, 2, 3, 4 vertices on top. You always have to try and imagine those vertices, edges, and faces that you cannot see. So this shape also has 8 vertices. Now this shape is a little confusing because I know it looks like a pyramid to us. However, it is not a pyramid. It is a triangular prism. Okay. You have to imagine that over here is a square, and this top, it's not a point. It's actually a point where 2 more faces meet. So it kind of looks like this. So it's kind of like the roof of a house. You have one side over here, and then you have another side on the back. Okay, and then you have the one down here on the bottom. Okay, so in this case, we know that we are going to have one face, okay, so one part of the roof, the second part of the roof, and then the bottom part right here, so that's 3. And then you have to have this triangle and this triangle, so this has 1, 2, 3, 4, 5 faces. Edges. This shape has the edges that make the triangle, so there's 3 here and 3 on the other side, so that's 6. And then you know that you need 1 to match each corner with the other, so you know you need another 3. So there's 3 on the bottom, 3 on top, 3 in the middle. It tells you that there are 9 edges. Any three-dimensional figure that is a prism, if you can figure out how many vertices you have or how many edges you have on the bottom, you know how many edges you have on the top and then how many edges you have in the middle as well. So if there are 3 edges on the bottom, there have to be 3 in the middle and 3 on the top. And then vertices, you have 1, 2, 3, 4, 5, and 6. You have these 2 problems in your notes. I would like you to try these 2 on your own. When you post to Edmodo, only do 1 post. So you have to post your answers to this one and to this one, and there will be a couple more problems that you have to do on your own as well. Alright, so prism, back to your vocabulary. A prism is a 3-dimensional figure formed with 2 parallel and congruent polygon bases. So what this means is you want to look for the shape that you only see twice. And in this case, you see a triangle here and a triangle here. Those will be your bases. Okay? They never touch. They're the same size. Okay? So they are our bases. A cube. A cube is a rectangular prism with faces that are all squares. Okay, so a cube is a type of prism, but more importantly, all the faces are squares, which tells you that all of the sides are congruent. Pyramids. Pyramids have triangular faces that meet at one point, a vertex, and a base that is a polygon. So it can have any base as its shape. It doesn't have to be a triangle. It can be a square. It can be a hexagon. It can be whatever polygon we want it to be, but all of the points meet at one, or all the edges meet at one point at the top. So here's an example of a square pyramid. It has a square as our base, and then off of each edge comes a face, and all those 4 faces meet up here at one point. So this is an example where even though you have 4 edges down here, yes, you have to have 4 edges in the middle, but you have no edges on top because there's not another square up here. In a triangular pyramid, so the base is a triangle, you only have 3 other faces that all meet at this point at the top. A cone. A cone has 1 circular base and 1 vertex. Okay, so it's kind of like a pyramid, but because it has a circle for a base and a circle is not a polygon, it is called a cone. A cylinder. A cylinder has 2 congruent parallel bases that are circles. So it's kind of like a prism, but again, because the bases are circles and circles are not polygons, it cannot be considered a prism. Okay, and these would be examples of cylinders. When you're drawing these shapes, what I have found to be helpful is to draw a circular base, draw another circular base, and then just connect them here. Now, this isn't perfect, but it gives you the idea of what a cylinder is. Sometimes you'll see it where it's drawn like this. So you have the top, and then you have the 2 lines there to help you visualize, and then you'll see this dotted line in the back. And the reason they put the dotted line there is because you in reality can't see that side. So it's the line that tells you that it's there, but technically you can't see it. So just like here you can't see the back of the circular base, if I do this, it gives you an idea of what that would look like. And a sphere. A sphere is the set of all points in space that are the same distance from a center point. So it has a similar definition as a circle, except for now, it's not just the center point and going out and around. It is any point in space. Okay, so if we have a center point in here, yes, it touches all these parts, but it also goes around and around. It's like a ball. So if you were to put a marble inside of a basketball, if you put that marble directly in the center of the basketball, it would be the same distance all over from all the other parts of the sphere. All right, in your notes you also have this page, and it asks you to identify each of these shapes. I want you to do this on your own, and this is the other part that I would like you to post to Edmodo. So you have to post your answers to these two problems, and make sure that you tell me. I will call this problem number 1, and you have to tell me faces equal, and then put your answer. And then we'll call this number 2. And then we can say that this is number 3, this is number 4, number 5, and number 6. So when you post to Edmodo, make sure that you put the number and then what your answer is to that problem. If you have any questions, make sure to post them on Edmodo or come with them in class tomorrow.